So the problems that I struggled the most with was problem 4, question part C through E, which is essentially all based on Young's modulus. The first one is pretty simple. I just messed up because I was confused over a formula, and I actually got the answer that's correct, but I changed it. So essentially, all you want to do is you want to find the interatomic stiffness between a bond between two zinc atoms, and we can do this if we use Young's modulus. We know that Young's modulus equals the interatomic stiffness divided by the diameter of the atom, which we found in the previous section. So if we just use some simple algebra, we get that Young's modulus times the diameter of the atom equals the interatomic stiffness, and we actually are told the value of Young's modulus. So if we just plug in both of these values, we get about 26 Newton per meters. For the next section, part D, it essentially asks how much or what percentage of a penny will be compressed once an elephant of 5,900 kilograms steps over it, and it gives you Young's modulus. So if we look at what the Young's modulus actually is composed of, we get that it equals force divided by an area that force acts on, divided by the change in the length or the compression / stretch, divided by the length. And if we rearrange this to solve for delta L over L, we get that it equals the force divided by the area of the penny divided by Young's modulus. The reason we want delta L over L is just because we want a percentage that it's compressing, and we know that we have the change in something over how much it compress, or the actual length of it, we'll get a percentage of it. Kind of like when you trying to figure out what you got on a test, you take how many questions you got right and divided by how many total questions there were. That'll give you a percentage of what your value, in this case delta L, is out of the entire value, which in this case is L. So if we simplify a little bit more, we get that force divided by Young's modulus times area will equal this delta L over L. And then the force that is acting at this point in time is just the gravity, so it's just the mass of the elephant times the gravity constant over Young's modulus times the area of the penny. Then we can see that after plugging in some values, we'll get an answer. So we have 5,900 kilograms times the gravity constant divided by Young's modulus, which is given in the equation. And then we're trying to get the area, so it's pi r squared. The reason it's pi over 4 here is just because the 1.905 times 10 to the negative 2 meters is the diameter, so we have to divide by 2, so it becomes pi over 4. And then it becomes pi over 4 because it's essentially supposed to be the radius divided by 2, but if you're squaring it, then it's becomes 4. So yeah, that's why it's pi over 4. But you'd get the same answer if you just did pi r squared, which you would just take the 1.905 times 10 to the negative 2 divided by 2 first, then square it, then multiply by pi. But in this case, we just kept we just pulled out the divided by 2 to the outside, but since it's squared, it becomes a 4. Once we plug all those values in, we get 0.00188, but we need to multiply this by 100 to get a percentage, just like when you get like 80 out of 100 questions right on a test, you get 0.8, but that's not your actual percentage. You multiply by 100 to get 80%. So yeah, and then the next question pretty much asks what percentage will the pennies compress if 10 pennies are stacked on top of each other, but the elephant is the same weight and all that. You actually don't need to do any math for this part. You just need to know that if springs are attached on top of each other, that way then the stiffness will be proportionate to the number of springs that are attached. So if you have 2 springs, then that spring will stretch or compress twice as much, depending on the stiffness, but it will stretch twice as much as just one of them, because the stiffness is decreased by a factor of how many springs there are. So in this case we have 10, which means that the pennies will squish 10 times as much, but it's also over 10 times as much distance. So that factor essentially cancels out, because we see here that the percentage that we're getting is delta L over L. So if they're both increasing by a factor of 10, then that'll just be the same percentage. So the answer for this question is just that it'll be the same amount of percentage, so 0.188% when there is 10 pennies stacked on top of each other.